Years ago, Mars was a very different place from the cold, dry desert we see today. Imagine a planet with blue skies, flowing rivers, and vast oceans. This is the vision scientists have of Mars, a world that was once hospitable and possibly habitable. Evidence from NASA's rovers and orbiters such as Curiosity and Perseverance suggests that Mars had liquid water on its surface. River valleys, lake beds, and hydrated minerals that only form in the presence of water point to a much wetter Mars in the past. Large channels, like Valles Marineris, stretching for thousands of kilometers and up to 10 kilometers deep, attest to the presence of flowing water that shaped the Martian landscape. Scientists estimate that Mars' oceans could have covered about 19% of the planet's surface, an area comparable to the size of the Atlantic Ocean on Earth. The northern plains of Mars are particularly interesting because they appear to have been an ancient ocean bed, possibly holding a body of water larger than the Arctic Ocean. Picture lakes dotting the Martian landscape, rivers winding through valleys, and even rainfall feeding these waterways. This vision is supported by the discovery of hydrated minerals and sedimentary structures that only form in the presence of water. But what happened to transform Mars from a potentially habitable world to the arid desert we see today? To understand this, we need to look at the planet's magnetic field, or magnetosphere, and its atmosphere. A planet's magnetosphere is crucial for maintaining an atmosphere. Earth, for example, has a strong magnetic field that protects us from harmful solar radiation and helps keep our atmosphere in place. Mars also had a magnetosphere in the past. A magnetic field is generated by the movement of molten metal in a planet's core. On Earth, this is known as the geodynamo effect, where the movement of liquid iron and nickel generates a magnetic field that extends into space. Mars, being smaller than Earth, had a similar but weaker magnetic field. Over time, Mars lost its magnetic field, likely because the planet's inner core cooled. Since Mars is smaller than Earth, it cooled more quickly. When the core solidified, it could no longer generate a magnetic field. Studies suggest that Mars' magnetic field disappeared about 4.2 billion years ago, leaving the planet vulnerable to the solar wind from the sun. Without a magnetosphere, Mars became exposed to relentless solar wind. These particles bombarded the planet, gradually stripping away its atmosphere. This process, known as atmospheric sputtering, took millions of years, but the result was devastating. Mars' once thick atmosphere was eroded, reducing it to a thin shell, less than 1% the density of Earth's atmosphere today. As Mars lost its atmosphere, it couldn't retain heat. The planet cooled, and any remaining water froze or sublimated, meaning it turned directly from ice to vapor and escaped into space. Mars transformed from a warm, wet world to the cold, dry planet we see today. The average surface temperature on Mars is now around -80 degrees Fahrenheit, far too cold for liquid water to exist on the surface for long. So, could Mars have supported life? Scientists believe it's possible. The presence of liquid water is a key ingredient for life as we know it. If Mars had water for long enough, it's conceivable that microbial life could have developed. Early Mars had conditions similar to early Earth, where life first emerged. Both planets had volcanic activity, a thick atmosphere, and liquid water, all essential ingredients for life. If life existed on Mars, it likely would have been simple, single-celled organisms. These microorganisms could have thrived in nutrient-rich waters, possibly around hydrothermal vents, much like early life on Earth. Hydrothermal vents provide heat and minerals that can sustain life, making them prime locations for the origins of life on both planets. Today, ongoing missions like NASA's Perseverance rover are searching for signs of ancient life. Perseverance is exploring Jezero crater, which once held a lake. By studying rocks and soil, scientists hope to find biosignatures, chemical or physical signs of past life. Jezero crater was chosen because its delta deposits are excellent at preserving organic molecules and potential fossils. Perseverance is also collecting samples to be brought back to Earth. These samples could contain clues about Mars' past climate and habitability, and potentially even fossils of ancient microorganisms. The rover is equipped with sophisticated instruments to analyze the chemical composition of rocks and soil, searching for complex organic molecules that could indicate past life. So, what's the importance of researching Mars' watery past? Well, it's important for several reasons. It helps us learn more about the history of our solar system and the conditions that lead to habitability. It also lays the foundation for the search for life beyond Earth. If life could arise independently on Mars, it would suggest that life might be common in the universe, potentially existing on many other planets. It's also important to know that Mars and Earth share many similarities. Both have polar ice caps, similar landforms, and a history of volcanic activity. By studying Mars, we can learn more about our own planet's history and how it has evolved over time. For example, Mars' volcanic regions, like Olympus Mons, the largest volcano in the solar system, could offer insights into volcanic processes that also occurred on early Earth. The knowledge we gain from studying Mars also prepares us for future human exploration. Scientists and engineers are still working on plans to send humans to Mars. Understanding the planet's history and resources is crucial for these missions. Future explorers could use local resources, such as extracting water from ice or using Martian soil for growing food, to support long-term missions. It could be that one day there will be a future where humans live and work on Mars. We could use the planet's resources, like water ice, to support life and create a sustainable presence. This dream is becoming closer to reality as technology advances. Concepts for habitats, life support systems, and transportation are currently being developed to make human life on Mars possible. The search for life on Mars is far from over. Future missions, including those by international space agencies and private companies, aim to dig deeper into the Martian surface and explore new regions. The European Space Agency's long-delayed ExoMars rover, set to launch sometime in 2028, will drill into the Martian subsurface to search for signs of life, where microorganisms could be protected from harsh surface conditions. Advances in technology are crucial for these explorations. Innovations in robotics, artificial intelligence, and remote sensing are enhancing our ability to study Mars in unprecedented detail. These technologies allow us to analyze vast amounts of data and make discoveries that were previously impossible. Studying Mars also helps us refine our search for life beyond our solar system. Exoplanet, or planets orbiting other stars, are being discovered at an astonishing rate. By understanding what makes a planet habitable, we can better identify exoplanet that might host life. Mars, with its similarities and differences to Earth, is a natural laboratory for these studies. And what if we did end up finding life, or past signs of life on the Martian planet? The implications of finding life on Mars would be profound. It would challenge our understanding of life's uniqueness and prompt us to reconsider our place in the universe. If life can arise on two neighboring planets, it might be a common phenomenon, suggesting that the universe is teeming with life. The many missions to Mars have been long and challenging. Early missions in the 1960s and 1970 seconds, like NASA's Mariner and Viking programs, paved the way for our current understanding. The Mars rover's spirit, opportunity, curiosity, and perseverance have built on this legacy, each mission contributing new insights and discoveries. Looking ahead, The future of Mars exploration is bright. Collaborative efforts between space agencies, private companies, and international partners are expanding our capabilities. The Artemis program aims to return humans to the moon, establish a presence, and perhaps build a moon base that will serve as a stepping stone for future Mars missions. And if we envision the bigger picture, Mars is not just an endpoint, it's a gateway. The technologies and strategies developed for Mars exploration will also help us explore other destinations, such as the moons of Jupiter and Saturn, which may also harbor subsurface oceans and potential life. As we look up at the night sky and see Mars shining bright, we now understand that this distant world could have once had the conditions for life. Our journey to uncover its secrets is just beginning, and who knows what we might find as we continue to explore the red planet.